Hi guys, we're back with math. It seems like forever since we've done math. Okay, so today we are going to start lesson 89, and it is about mixed numbers and improper fractions. So, why don't we do the problem solving first? Because I know you all have your whiteboards with your problem solving that you've already done. If you don't, shut this video off and do your problem solving. You get a lot more out of something if you try it, and then you're probably going to get it correct. But then if you don't, you can kind of see where your thinking might have gone wrong, so that you don't make that same mistake again, okay? So let's go over the problem solving. The thing that we had to do was use the Venn diagram. Notice we're back to the Venn diagram, which I love, or Euler diagram. They're a little bit different, but a lot of people equate them to the same. So let's do the first part, is understand the problem. So, of course that doesn't work. Let's try purple. All right, here we go. So we're going to understand. So we have a Venn diagram, and our problem told us that the one on the left had multiples of 3, and the one on the right was even numbers. And then outside of those circles was neither, okay? So the problem wants us to copy that Venn diagram and then put in the numbers 9, 10, 11, and 12 where they go. Okay, so let's do that. So we've understand. We're going to do our plan, and our plan is draw a diagram because it tells us what they want you to do right away, right? Okay, so hopefully you have something for understand. You wrote down little notes. When you understand a problem, you have to write down, what is the problem telling you? What information did they give you? What is it that they want you to do? So if you don't have that written down, when you go to solve the problem, you may forget something. And if you forget something, it could be something that's not important, like John wanted us to do this Venn diagram, and he needed it for his assignment in math tomorrow, and he asked you to help him, and you didn't want to, but your mother made you. I mean, okay, that's all information about the problem, but is it critical information to help you solve the problem? So you don't write down everything about a problem that you might have, but you need to write down the part that's going to help you identify what the problem is, and then what is it that they want you to do, okay? So that's very, very important that you guys get that skill. You don't have to write down everything, because it would take you forever if you had to do that. And then the plan is draw a diagram, because they've asked you to solve it that way. They in the problem itself, it told you the plan. Okay, so I'm going to erase that part just so we have a bigger work surface here. So now let's go on to solving. So we've got solve. So we're going to draw our first Venn diagram. The first part of it is a circle, and this is multiples of 3, and I'm going to abbreviate it MULT. So multiples of 3, and then it has, remember the last time that we did Venn diagrams, I talked to you about you would have this intersecting part here where the circles have something in common. And so the example I gave you was, if this circle was I1 girls and this was I1 boys, there's no boys that'll go in the girls circle, there's no girls that'll go in the boys circle. But we could do it this way: I1 girls and I1 boys, and here everybody would be here because everybody is an I1 student. Okay, so they kind of intersect that way. All right. Oops, my eraser's falling apart here. Let's get this put back together. All right. So today, the left circle's multiple of 3. The right circle is even numbers. And our problem gave us some numbers that were already entered into our diagram. So they had 6, which was in the intersection, and 4 and 1. So let's go over why those numbers are where they are. The 1 is neither a multiple of 3 nor an even number. So it's not going to go anywhere here on our diagram. It's going to be out here outside the circle. 4 is an even number, but it's not a multiple of 3. So it's only in this circle for even numbers. 6 is an even number, and it's also a multiple of 3. So it would go in the intersecting circle because it could be in either circle. So it puts it in the middle, the intersection, where it shows it can be either one. It's actually both. Okay? All right. So where would we put 9, 10, 11, and 12? So let's just, I'm going to write those numbers down over here so that we erased our understand. So we'll have those to work with. Let's just go down the list and work them. 9. Is 9 a multiple of 3? Yes, because remember, what is multiple of 3? What does that mean? A multiple of 3? It means when you count by 3s, you would say this number. So 3, 6, 9. It is a multiple of 3. 3 times 3 is 9. All right? So remember, it's not a factor of 3, because a factor of 3 means it would be a number multiplied by something else to get 3. And there's no number that you can multiply by 9 to get 3. So it's not a factor of 3. It's a multiple of 3. Okay? So multiple of 3 it is, indeed. Is it an even number? No, it's an odd number. So it can't go here, and it can't go in the intersection to be in both. It has to go here. All right, so we've done 9. What about 10? Is it a multiple of 3? No. Is it an even number? Yes. So it's going to go in the even number circle. What about 11? Is it a multiple of 3? No. Is it an even number? No. It's going to go outside with the 1. How about 12? Is 12 a multiple of 3? 3, 6, 9, 12. Yes. Is it an even number? Yes. So it's going to join 6 here in the middle. All right, so we placed all 4 of those numbers. And hopefully you followed along. If you didn't get this answer by looking at your board, hopefully you can see what you did. Okay? All right, so let's check it. That's our last step. Let's see. Did I use all of the numbers? 9, 10, 11, 12. I used all the numbers. Did I use the diagram? I used the diagram. My numbers check. Okay? All right. That was problem solving. If you want to go through that, you can always remember. You can always rewind. And, this thing is just falling all apart here. Jeez. Strong magnets. Can't get them out. All right. So, you can always rewind and watch the video again, if that would help you. So I think Venn diagrams are kind of fun. I always enjoy working with Venn diagrams. All right, our math lesson today is on mixed numbers and improper fractions. So let's talk about the kinds of fractions that we have. We have a proper fraction. So Pinky's up when you say that. We have a very proper fraction. And proper fractions, what does that mean to have a proper fraction? What does it mean to be a proper fraction? What does that fraction look like? It's very proper. Pinky's out. Very proper. Remember, your numerator is on top, your denominator is on the bottom. A very proper fraction, the numerator is always smaller than the denominator. So, 1/2 is a proper fraction. I hope you're saying your British accent and your pinkies are out and you're saying this with me. It's very mathematical, okay? Got to get this, the right mathematical vocabulary. And you have to say proper when you say that kind of fraction. That's the way it is. So a proper fraction, the numerator is smaller than the denominator. Okay, then we have the old improper fraction. What's an improper fraction? Got a big improper fraction. What's it gonna be? The exact opposite of a proper fraction, where the numerator is bigger than the denominator. That looks strange. It's very improper. Okay? All right. That leaves us with the third kind of fraction that we work with. Well, it's really not a fraction, but it has a fraction in it. And that is called a mixed number. Now, a mixed number has a fraction in it, and it's always a proper fraction in a mixed number. And it also has another kind of number that goes along with the fraction because it is a mixed number. Do you remember what that number is called that goes along with that fraction? Well, is anybody going to say it? Thank you, Zane. Thank you. Yes, a whole number. Yeah, so if you had 4, 4 1/2 is a mixed number, okay? So you've got your proper, numerator is smaller than the denominator. Your improper, your numerator is larger than your denominator. And your mixed number, where you have a whole number and a proper fraction, okay? Now, what we're going to learn today is how do you model those. And when we talk about modeling, you're going to draw fraction models. Now, if we were in the classroom, I have our fraction models that we could work with. Don't have those, so we're going to move to the very best thing. You have your whiteboards. So I want you to draw them for me. The first thing I want you to do is I want you to draw a picture to show me that 1/2 equals 3/2. I'm going to write that down because I know that sounds funny. 1 1/2 equals 3/2. Remember, everybody has a little problem saying that because they always want to go 3 2s. It's halves. 3/2. 1 1/2 equals 3/2. How can you draw a picture to prove that? Because I always want to say, our favorite question, why? Why is that true? 1 1/2 equals 3/2. Well, let's draw a picture to prove it. Here we go. Here is 1 1/2. Okay? And I want you to draw pictures. You see if you can draw a picture to prove it. I'm going to draw my picture to prove it. You do it on your whiteboard. See what you get. Okay, so what I did was I drew 1. There's 1 hole, and I colored it in. That's 1 hole. Then this is a fraction for 1 of 2 halves. So I had to half my circle here, and I just colored in 1 of them because that's what I wanted. I have 2 pieces. I wanted 1. So here's 1 1/2 colored in. Now, over here, it's 3/2. So I had to draw a circle that was halved, and this circle is halved. And then how many of these halves do I need? I need 3 of them. 1, 2, 3. Now look at my pictures. I know I made this one kind of big, but let's pretend like Mrs. Pullman was able to draw perfectly congruent circles. Okay? They're the exact same thing. Here's a hole, here's a hole. Here's a half, here's a half. So 1 and 1/2 is the same thing as 3 halves. Okay? Now, let's do that again. Erase your boards. I'm going to give you a problem. You see if you can draw the picture, and then you'll compare yours to what I put up here. Okay? So I want you to draw a picture that proves 2 3/4 equals 11/4. 2 3/4 equals 11/4. Draw circles to prove that. Why does that work? Okay, I'm going to start with the first half. 2 3/4. Well, I already messed up. Let me fix this. 2 3/4. Okay, here we go. You have to have 2 holes. So that's easy. I know if I've got 2 holes, I've got to have 2 circles, right? 2, 2, 1, 2. Then I have a fraction. So it's going to be a circle divided into pieces. How many pieces? My denominator tells me. 4 pieces. Okay? So let's color in 2 3/4. There's 1, 2, 1, 2, 3. Because I only want 3 of the 4 pieces. So that's what 2 3/4 looks like. Now, let's draw. Have you guys drawn your 11/4? You guys work on that. I'm going to work on it too, and let's compare, okay? Okay, I have my circles drawn. Now, you'll notice I didn't draw 2 whole circles because I don't have a whole number. So I don't have any whole circles. Look over here. I had a whole number in my mixed number. I had a whole number. This is a mixed number. It has whole and a fraction. So I had whole circles. Over here, I have an improper fraction. So I don't have any whole numbers. But I'm going to have circles that are divided, and how many pieces will each circle have? It has to be the number that's on that denominator. They have to have 4 pieces. Okay? How many of those pieces do I need? I need 11 of those 4 pieces. So let's see what I get. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, so I believe that I have 2 3/4 and I have 11/4, and it looks like here's a whole one, here's a whole one, here's a whole one, here's a whole one. This is 3/4, this is 3/4. They are indeed equal. And here is my diagram to prove it. Okay? All right. Let's do another one. I'm gonna give you the problem to prove, and you draw your circles and prove it. 1 3/4 equals 7/4. 1 3/4 equals 7/4. So draw your pictures to prove it. So I always start with the left side, the mixed number. I always think that's the easiest one to draw because I know I'm going to have a whole number, 1. And then this is my fraction, so I'm going to have a circle, and it's going to be divided into 4 pieces because my denominator is 4. So I've got 1 and 3 of these 4 pieces. Okay? That leaves me with this side, 7/4. So I know I'm going to need a circle divided into 4 pieces because that's my denominator. So here's 4 pieces. 1, 2, 3, 4. That's not enough because I need 7. So I'm going to draw another one. Divide it into 4 pieces. 5, 6, 7. Do they equal? Whole, whole, 3/4, 3/4. They indeed check. Let's do another one. All right, you got 2 1/2 equals 5/2. 2 1/2 equals 5/2. Practice saying that, 5/2. A lot of people don't know how to say that. 5 2s, 5 5/2. 5/2. Okay, 2 1/2 equals 5/2. Draw the left side because it's the easiest. There's my whole number, and there is my fraction. Now, 2, 1, 2 1/2. 5/2. I know I'm going to draw a circle. I know it's going to have 2 pieces. There we go. 1, 2. I need 5, so I'm going to keep going. 3, 4. I still don't have enough. 5. Whole, 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 half, half. They indeed equal. Okay? All right. So if you want to practice that, your lesson practice for 89, we did the first 2 together. You can practice that third one. If you just do not understand what we're doing, you have my phone number. I put it on various things, 918-230-6. You know what? I don't know that I'm going to give out my phone number because I know that this is on a video. So I think you have it written down in our school materials. So you know how to get a hold of me. All right. So I've looked over the problems, and I think you're going to be fine. You are going to do the, I believe I have odd problems is what we're going to do. Coach divide 30 periods. Okay, so number 1, you're not going to have a problem with that. Number 3, you're good. Number 5, perimeter, you can do that. 7. Okay, now number 7, you're going to have to determine milliliters, pints, liters, cups. If you don't remember that, remember underneath the number 7, there is lesson 40, I believe it is. You can go back and it's going to do a review with you on those quantities, those amounts, okay? Everything else, I think it looks pretty good. You shouldn't have too much trouble. And if you do, you know where to find me, right? Okay. I wanted to show you something. I wanted to show you a little trick, a little shortcut for changing, because you'll get into this. I don't know if we'll get into it this year, but I know you probably will next year. So and this is nothing that you have to know, but just something I thought you might find is fun, is a shortcut for changing a mixed number into a proper fraction. Because if we say 2 1/2 equals 5/2, how can we get there quickly? Here's a little trick. If you have 2 1/2, whole number and a fraction, if you take, get some of this so it doesn't confuse you, your whole number and multiply it by your denominator. What is 2 times 4? What is 2 times 2? I gave you the answer. 2 times 2 is 4. Add the numerator, plus 1 is 5. And use your same denominator. 2 halves equals 5 halves. 2 1/2 equals 5 halves. Let's take some of those problems that we just did. 1 3/4 equals 7/4. And we drew a picture to prove why that's true. Let's do our little shortcut. 1 3/4. So we take 1 times 4, the whole number times the denominator is 4, and add the numerator, 7. 7/4. Look at that. Why does that work? Why does that work? It's not a, I always tell you, show you a little trick. It's not really a trick. There's always a reason why it works. And in math, ladies and gentlemen, if you learn nothing but this, if you never understand why you are doing something in math, stop and ask. You need to understand why you are doing what you are doing. It will only help you as you get in advanced math. Okay? So, and a teacher will never have a problem with you asking. I do not understand why. And it's very important that you understand why math works. Okay? So, why does this work? Well, let's take a look at it. I think it's simpler if we go back to this problem, 2 3/4. Let's take a look at it. What are we saying about this problem? How many fourths do we have? We have 2. 2 fourths. Okay, 2 of the fourths. All right, so the number of fourths in 2, how many fourths are there? There's 4 fourths in 1. So if I had 2, how many would there be? 8. So you can always multiply this whole number by the denominator because it tells you how many parts would be in 1. Then you're just adding the extra parts that you have up here. And that's why it works. Now, should you be concerned right now in 3rd grade that if you understand why this works? I'm not concerned that you understand why that works right now. Remember, a lot of times I tell you I like to show you some things so that when you, next year, when you hear this or you see this, or this is explained to you, you're going to go, okay, yeah, I remember something about this in 3rd grade, right? Okay, so that's where we are right now. What I want you to be able to do is be able to draw why does 2 3/4 equal 11/4. You need to be able to do that, okay? And if you're having problem with that, let me know. And I can get on Zoom with you and we can draw on the whiteboard together and we can work one-on-one for as long as you want to work, okay? I've done that with several students and it seems to work really well. Okay, so your homework is Lesson 89, Odd Problems. Happy mathing!